Alright, this is part 3 of a lesson about congruence. In this video we're going to focus on congruent triangles. Are they congruent? Which postulate? Side, angle, side, angle, hypotenuse, leg, angle, side, etc. Okay, we have 5 ways of proving triangles are congruent. Side, 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 angle, side, angle, side, or hypotenuse, leg. Of all the random ways of setting up these letters, they all work except for these two. Angle will not prove that two triangles are congruent, nor will two sides and the angle that's not between them. Okay, so as long as you know that these two don't work, SSA and AAA do not prove triangles congruent, then pretty much anything else you think of is going to work out just fine. Okay, let's see, why will these two triangles be congruent? For this one will be side, angle, side. Alright, I have two sides and the included angle, the angle in the middle. So those will be congruent. What about this one right here? I'm only showing an angle and a side congruent to an angle and a side. But I also know that vertical angles are congruent. So that gives me an angle, a side, and an angle. So this will be angle, side, angle. Alright, it's two angles and the included side, the side between the two angles. Alright, looking at this one. Again, I have vertical angles, so go ahead and mark those even though they weren't already marked. Now you see I have side, angle, side. I have two sides and the included angle. So side, angle, side. Looking at this one, they share a common side, so you can go ahead and mark the common side as congruent. So then looking at the other markings, I have an angle, a side, and an angle. Angle, side, angle. Okay, it's not angle, side because it's two angles and the side in between them. Alright, looking at number 5, all three sides are congruent to all three sides. So that's the side, side, side postulate. Okay, looking at this one. Well, we have an angle, and a side. So that's going to be angle, side. Alright, the reason why it is not angle, side, angle, okay, see, we have two angles and a side, so somebody's going to think, okay, angle, side, angle, like that. So let me try to make you understand why that's wrong. If it's going to be angle, side, angle, I need two angles and the side that's between them. But you see, I have my two angles are here and here. But the side is not between them, alright? If it was going to be angle, side, angle, it would have needed to be this side right here between them. Okay, so since it's not between, then that makes it angle, side. Number 7. Now, I see the right angle, 90 degrees. That means there's a chance that this will involve the hypotenuse leg theorem, the HL. But not necessarily. First, let's mark the thing that's not showing. This shared side will be congruent for both triangles. Now, is this hypotenuse leg? No, because the hypotenuse is out here, and that's not one of the congruent sides. But they are congruent, by side, angle, side. Just treat it like a regular triangle. So I have two sides and the included angle, so that's side, angle, side. Okay, now looking at number 8, at a glance I'm thinking there's not enough information. Alright, I'm going to look at it more closely, but I'm thinking this is none. What we have two sides that are congruent, and I'm assuming that they mean for this whole side to be congruent to that whole side, not just the piece that's out here. Anyway, that's not enough information. We just have two sides. We don't have any angles. We don't have the third side. So that's not enough information. Okay, what about number 9? I have two sides and an angle. So if I were going to make up a postulate for this, it would be side-side angle. Okay, I'm being careful not to write it the other way. Angle side-side would mean the same thing, but that's a bad word, which is a hint to me that this is not one of the postulates that proves that triangles are congruent. So that's why instead we're going to just put none. Alright, side-side angle doesn't work. Okay, so that's none. Now, here I can mark this third side as also congruent because it's a shared side. So that makes these will be congruent by the side-side-side postulate. Okay, H is the midpoint of QK. Alright, so far that tells me that these are congruent. What else? The measure of angle MHQ, okay, MHQ is right here, and that's congruent to angle DKH. Okay, DKH is right here, so those are congruent. Okay, the measure of angle D is congruent to the measure of angle M is congruent to angle D. Alright, I guess let's keep the same color. So M is congruent to D. Okay, so why are these two triangles congruent? This would be the angle side postulate. Angle side. Alright, it's not going to be angle side angle, even though that's also two angles and a side, because the side is not between the two angles. Alright, so it can't be angle side angle. Now, here they're prompting us to put the congruence statement. So congruent to triangle. Well, D corresponds with M, so I'll put that first. K corresponds with H in the other triangle, so I'm going to put the H next. Alright, so I've done M and H, so that leaves Q. Alright, now number 14. Angle P is congruent to angle R. So this is congruent to that. TP is congruent to SR. So TP, SR. Q is the midpoint of PR. Alright, if that's the midpoint, then that means this will be congruent to this. So why are the triangles congruent? Side, angle, side. Okay, let's make the congruent statement. Well, Q will be matching for both triangles, so I'm going to go ahead and put Q first, but T is corresponding to angle S, so S comes next, and then P is corresponding to R, so R comes third. So that's number 14. Okay, number 15, GN and MK bisect each other. Alright, that means that L is going to be the midpoint of both segments. So GL and LN will be congruent, and ML and LK will be congruent. Also, we have vertical angles are congruent. So that means these triangles will be congruent by side, angle, side. Okay. Notice how the congruency is going sort of diagonal. Alright, GL is congruent to LN. That means angle G is going to be congruent to angle N over here. Okay, so when I make the congruency statement, I need to match diagonally. G will match with N, and then okay, L is going to be the same point for both, but then K is going to be congruent to M. So that's my statement. Okay, number 16 describes triangle ABC congruent to triangle DEF. It might be helpful to draw a picture. Okay, so triangle ABC is congruent to triangle DEF. So that means these are congruent, and these are congruent, and these are congruent. Or looking at the angles, we have these, and these, and these. Wait, I missed one, didn't I? Alright, that's a lot of marks, but you get it. In fact, the markings are bothering me. You get that all these, I lined them up. You get it. Alright, so AC is 2x plus 7. Okay, so this is 2x plus 7. DF is 5x minus 5. Okay, good to know. Let's start with that before I get into the rest of it. Right there, these are corresponding sides. So you know that they're going to be equal in length. So I should be able to set up and solve that equation. So 5x minus 5 should equal the 2x plus 7. So let's go ahead and solve this. So subtract 2x from both sides. That's going to give us 3x minus 5 is equal to 7. If we then add 5 to both sides, that'll give us 3x is equal to 12. Divide by 3. And we know now x is equal to 4. Okay. Now that I know that x is equal to 4, alright, so I found x, that's great. I should now be able to find EF. So EF is 5x. So that makes this 5 times 4. So EF is 20. Okay, that's horrible. Okay, so that is it for number 16. Alright, for number 17, we need to find the values of x, y, and z that make these triangles congruent. And the way they've done the letters, both triangles are oriented the same way. So A corresponds with D, C with E, and B corresponds with F. So, for example, the x plus 15 and the 2x plus 5, those are corresponding sides. So they should be congruent. So I can make an equation out of those and say 2x plus 5 should equal x plus 15. So we can solve that. Let's subtract x from both sides. So that's going to give you x plus 5 is equal to 15. Now subtract 5, and that's going to give you x is equal to 10. Okay, so that's one of our answers. Now how about the y's? We found x, now let's go after y. So let me just unhighlight those. So now with the y's, I have a y expression here and here. And again, those are corresponding parts. Okay, so that means I should be able to set them equal to each other. So 8y minus 20 should equal 4y. Okay, I'm just going to subtract 4y from both sides. Okay, this will be 0. Okay, don't be scared of 0, just put 0. So this is going to give us 4y minus 20 is equal to 0. And then we will add 20 to both sides. So that'll give us 4y is equal to 20. And then we will divide both sides by 4. So that'll give us y equals 5. Okay, and finally, what about z? So we have a z expression here, and we have a z expression here. Those are corresponding, so we should be able to set those equal to each other as well. Okay, so 10z minus 5 should equal 3z plus 9. So if you subtract 3z from both sides, okay, so that is going to give you 7z minus 5 is equal to 9. And then we would add 5 to both sides. Alright, so that will give you 7z is equal to 14. And then we would divide both sides by 7. So that would give you z is equal to 2. Okay, so that's how you find your x, your y, and your z. Alright, let's do one more problem on this video. Okay, we are looking at a 2-column proof, and we're given all the statements, and we just need to supply the reasons. Okay, so we're given that AD is congruent to CB. So let's mark that. AD is congruent to CB. We're also given that DC is congruent to BA. Okay, so that's DC is congruent to BA. In addition to what's given, we know that AC will be congruent to itself by the reflexive property. So we can go ahead and mark that. So looking ahead, we can see that these two triangles will be congruent by the side, side, side postulate. So this is going to show up later. But it's good to think ahead. So obviously, statement number 1 is just the given. So we'll put that as our first reason. Okay, then statement number 2, AC is congruent to AC. Okay, that's the shared side, but anything congruent to itself, that is the reflexive property. Okay, that covers a side, and a side. We have 3 pairs of congruent sides. So now we can say that the 2 triangles are congruent to each other by the side, side, side postulate. Okay, and that's it. So this is a good place to stop this video. End of the page. Alright, we have one more page of problems left. So we'll be back in the next video, part 4 here. And we're just going to continue working with our 2-column proofs. Alright, practicing more with that. And we'll finish up with practicing how we copy angles and construct an angle that's twice as long. Alright, long is the wrong word, but twice as big as the given angle. Maybe I could say large. I'll see you on the next video for that.